Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 200 gigabit network, all controlled by a brand new API, you've got everything you need to scale. Go to podcastinit.com/Linode to get a $20 credit and launch a new server in under a minute. And visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. Your host, as usual, is Tobias Macy, and today I'm interviewing Andrew Godwin about Django Channels 2 and the ASGI specification for modern asynchronous web protocols. So, Andrew, could you start by introducing yourself?
Hello, yes, I'm Andrew Godwin. I am a, shall we say, Django developer at large. You may know my work on things like South for Django or Django migrations in the past, and as Tobias just said, on channels these days too.
And do you remember how you first got introduced to Python?
I sort of do, yes. It was back in sort of the mid 2000s, I think it was, and I was coming from PHP and I was thinking, well, PHP is great. I'd written a few things. I released an open source library, but I was like, I really want to change language, right? It's like I actually got my first vulnerability report of my open source PHP project. It's like, well, at the time it was like PHP is by nature unsafe, and like PHP 4 and 5 weren't the best. It's much better these days. And so I sort of looked around and I tried a few things. I tried a very early version of a few different things, but weirdly, TurboGears, one of the older Python web frameworks, was my first introduction to Python. So I found TurboGears and I was like, oh, this is great. It's sort of, Python is like a good language. I sat down and learned it that way. And it was sort of solidified when I think it was like the next year, maybe later that year, I sat down with Simon Willison. I went to work at the company he was working at the time, and he very excitedly ran over and was like, Andrew, you have to learn this Django thing. It's very exciting. And so his enthusiasm sort of sealed me into the Python web ecosystem and taught me a lot of the Django I know today.
Yeah, it's not often that you hear TurboGears mentioned, and I remember when I was first getting into Python, I came across that as well and was very interested in it, and I never actually built anything with it, but it's something that I always periodically go back to and think about and wonder why it doesn't get as much attention these days as some of the other frameworks that everyone's talking about.
Yeah, and it was a fascinating thing too, right? Like they had this very clear vision of like there are 4 separate components, and then TurboGears is the glue between them. I think maybe they're, like the templating framework was very XML based, which probably didn't work in their favor. But it was a really nice project, and like I think one of the things it had I liked was it had good documentation. I seem to remember as well all the time. Like there's a great tutorial. I got going really quickly.
And so now that you've been involved in the Django world for a while, there are a number of cases where people are looking for support for different web protocols that don't fit nicely inside of the WSGI protocol. So can you just start with a brief overview of the problem that Channels was set out to solve?
No, definitely. So it starts again, like I think 5 or 6 years ago, like when WebSockets is first being sort of thrashed out. The WebSocket specification was this sort of very developing protocol at the time. There's like 3 or 4 major revisions. There were a few years there where if you didn't have the most recent version of Chrome, it would be the wrong version. It wouldn't interoperate properly. I started off sort of looking into the protocol and working with, at the time, hang on, let me just think of the right thing here. It wasn't G-Event, it was the other thing. Events, yeah. So at the time I was working with Eventlet. So I took Eventlet, which had an old copy of the protocol that didn't work anymore. And I sort of took that, upgraded it to the new version of the protocol, and was like, a little bit fascinated at the time by that. That sort of sparked my initial interest. And then later on, sort of work happened around Django and this stuff too. So Aymeric Augustin's work on WebSockets with Django, of course, was around this time. And he did a few sort of interesting demos of that stuff. And so I sat down, I looked back at the problem and was like, okay, we have this protocol. It's so unlike HTTP that there's no request response flow at all. How could we possibly handle this in Django? And without like resorting to hacks about like, oh, it's like fake web requests, or it comes through as posts and gets, or there's some kind of weird like long polling thing you do. And so I sat down and I sort of sketched out the first version of what became Channels 1 back then, and sort of built it out. And this is very much sort of filling the hole that I had after migrations. And then so I did the migration support in Django, had about a year off for just burnout basically from that project. And then this is sort of what filled that gap. And over time, I sort of made channels, played around with it. People seemed pretty interested. I was doing it. So I sort of built that up and developed it into the first version of channels as it was. And kind of from the beginning, it wasn't just about WebSockets. It was a sort of direct focus on how can we have support for more than just HTTP. Like even back then, WebRTC was coming up as a protocol too. And as the time goes on, I suspect we're going to have more and more different protocols that the web is built upon. I think just today, there's an announcement from I think it was Cloudflare, like, oh, we've now support IPFS, which is sort of this weird decentralized interplanetary file system kind of web thing. So like there's a lot of different protocols. The web continues to evolve. It continues to be more like JavaScript based and more interactive. And like that to me was the driving force behind like making something like channels.
And do you think that if we didn't have a strong story for native asynchronous support in Django, that it would eventually start to fade into the background and be replaced by some of the other asynchronous frameworks that have existed in Python for a while, and with new ones that are starting to come in and be natively asynchronous on top of the new built-in async support with Python?
I was never quite sure about that one, right? Like the first version of channels was entirely separate. It ran on Python 2, so I had to basically work on a synchronous version of Python. And it's one of those things where I was never quite sure if something would come up to solve it. I think someone always steps in to help this stuff. And in this case, that ended up being me and a few other people for this one. But I do think something would have happened eventually. The question is if it would have been involving Django or a brand new thing. Like we've had technology around for a long time. Like Twist has been around forever doing asynchronous stuff on Python. But also, even in the last like 3 or 4 years, there's been Tornado and other solutions like that, and building on top of different C bindings. Like there's so many different approaches that something would have come through eventually. But I think, and this is leading into channels too, like the idea of a core central Python async framework is really useful from here is the sort of guiding light everyone can go towards, like trying to have some kind of single way of solving this stuff.
And I think too that with how mature and long running the Django project is and how many different projects have been built on top of it, that by having it eventually fade out, it would introduce a lot of extra rework by people who have already invested so much time and effort into these existing applications, that having a way to give them a migration path into this new world of asynchronous protocols while still supporting the applications that they have been maintaining for all this time provides a lot of value to the community and to all of the different businesses and people who have been building and maintaining these things.
Yeah, like one of the things I've learned, like as I've sort of done more and more open source maintenance, is like the easy thing is not adding new features or making new projects. The hard thing is not adding new features or making new projects. The hard thing is, in fact, trying to get people from what they're on now to that new thing without a rewrite. Like Django has had over a decade of success in that arena, like pretty much always backwards compatible for a few releases. There's a nice upgrade path. We try and do well by users as much as we can. And it's very easy to just like, I could have gone away and done a whole separate framework from scratch and ignored all the learnings of the past, maybe tried to make it a spiritual version of Django too. But I really wanted to try and integrate it, like take what's good about Django and add to it on top of that stuff as well. And that was almost the reason by like why I kind of made more work for myself in that way. But I think the end result is also very useful.
Yeah, I know that I've been hearing about channels for a while, but it never really seemed to hit that critical mass of everybody's talking about it, partly because of the fact that it is this sort of bolt-on application that requires an extra process with the Daphne server and the Redis server for being able to manage the communications between the different processes. And we're getting a bit deep into the weeds about the differences between the 1.x and 2.x release, so I'll leave it there for now. But for somebody who is familiar with working in the Django web framework as it is today, and they have an either existing application or they're starting a new one, what are the steps that are involved in integrating channels back in the 1.x release and now with 2.x?
Well, so the key thing with 1.x, as you just mentioned, is that it required an extra component. So you replaced your web server, something like, say, like Gunicorn, with Daphne, which is the WebSocket's sort of ASGI version 1 enabled web server. And then you also needed a way to transport stuff between the web server and Django. So Channels 1, because it ran on an old version of Python, it couldn't be natively async inside the same process. So Daphne was running on Twisted. It was natively async in that sense, but Django wasn't. And so we ran them in separate processes, and Redis was our sort of bus between the two of them. That caused all sorts of issues, not only with scaling that particular problem, but like just reliability and like adding an extra sort of moving piece to your deployment stack was not necessarily the best thing to do. In channels 2, it's a lot simpler. Everything now runs in the one server in the one process, like it always has done with Python. So you sort of just swap out your existing Python web server for Daphne or for Unicorn or one of the other several ASGI web servers we now have.
And so, as you mentioned, the transition from the 1.x to the 2.x version of channels was a significant amount of rework and redesign. So I'm wondering if you can discuss how the current system is architected and how that differs from a standard Django web application that somebody might already be running today.
Yeah, so like one of the key things with channels 2 was to take some of the lessons from channels 1 and a lot of the basic design structures, but also try and incorporate like all the stuff that Python 3 had brought, like native async and that kind of thing. So the key thing is channels 2 is by default non-invasive. Like you can install it as a dependency, you can switch over to running on Daphne or another ASGI server, and your site will just run as expected. All the defaults are going to work as you expect. And then what you do is in places you want to have asynchronous support, so where you want WebSockets or long polling or another protocol, you can then go into those places and write a consumer, which is sort of the asynchronous channels version of a view, and say, okay, so this particular part of the site, this WebSocket thing, this has asynchronous code. This is going to do polling, it's going to do requests, whatever you want it to do, but you still write your views as well. So the idea is you want to keep that traditional, normal Django world that everyone understands and is easy to debug and all that kind of stuff in one place. And then the asynchronous stuff is not quite separate, but it's got a nice outline around it. Like here is asynchronous code. And because asynchronous code is harder to write and to debug, it helps keep that surface area smaller. There's no sort of trudging through loads and loads of weird asynchronous versions of bits of Django and like no need to rewrite all your views in an asynchronous fashion if you don't need to. A big part of my philosophy is asynchronous code is harder to write and it's not always necessary. Synchronous code is often just what you need and runs perfectly fine. So giving you the free option to choose between the two of them is kind of what I'm trying to aim for there.
And when you're writing an application that's using channels, do you have any general guidelines as to when you want something to be asynchronous versus synchronous? Or do you just start with the synchronous version and then do some profiling to determine that this is IO blocked and needs some additional parallelism to increase the performance?
So it depends. There's two different answers to that question. The first one is that if it's a feature that absolutely requires like a WebSocket, like, oh, we're doing a live chat, then the answer is very clear up front. Like the chat protocol has to be a WebSocket at that point. But there are some other things too, where it's like, oh, like we could change this to a long poll rather than sort of a short poll, or, oh, we found out we could do maybe some database requests here in parallel to improve it. But in general, if it's not super obvious, I would encourage building it synchronously first. And as you say, then doing some profiling or trying to just work out what your sore spots are. Because sometimes you're not going to get it right. Like asynchronous code is strange. It might seem obvious that you can just take these queries and run them in parallel, but it may not be much better. You may be wasting a lot of development time for not much gain. So in general, building synchronous first, building short polling first, and then trying to understand where your state is and what your usage patterns are and that kind of stuff, I think is how I encourage it. Unless you are already experienced with async stuff and know, okay, I can jump in here and do this the right way.
And in terms of synchronous versus asynchronous, when I was looking through the documentation, there were a number of mentions of the Django ORM and requiring that bridge between the synchronous land and asynchronous land because of the synchronous nature of those database calls. And I'm wondering if there are any limitations that imposes by not having the ORM layer natively asynchronous, or if it doesn't really seem to give a lot of benefit by trying to enable asynchronicity in the database, and it's just too much additional overhead for what it would gain you.
So there's a lot to be gained from asynchrony in the database. Like it's maybe one of the biggest areas most sites could optimize on. The problem is right now it's still kind of a young field in Python, and that means that the tooling is not there necessarily to support it. Things like maybe like prefetch related in Django, we could maybe optimize those as you run in sort of a parallel fashion if there's more than one of them. But the problem is ultimately like Python now has asynchronous database bindings for most big databases, but Django doesn't. And we have to sort of first take that layer and have an asynchronous version of Django's things like the query planner and the thing that makes all the model instances and all the sort of internal caches and connection handling. There's a lot of stuff inside there. In some ways, the ORM is by far the biggest and most complex part of Django. But I do think there's a lot to gain there. And like one of the things I really want to focus on maybe the next year or so is how do we really make use of that potential? Like how do we take asynchronous database access and not just make it possible, but make it easy? Like how do you make good access patterns and API design that encourages safe database queries, but also making them fast? Things like, if you naively just do every query in parallel, you're going to end up reading stuff before you've written it, right? Like there's a lot of things that you assume that come with synchronous building. You've really got to sit back and like think differently about asynchronous stuff. And like Django's job has always been to give you a nice, safe way to do stuff. So how do we get there? How do we make it so you can do things in parallel easily and safely without it requiring a whole load of like new re-education on your part?
And as we're talking about the asynchronous versus synchronous nature and some of the difficulties in being able to reason about what's happening in the asynchronous aspects of the application, I'm wondering what you have found to be some of the biggest stumbling blocks or points of confusion, both for your own work on building these asynchronous applications and working with these asynchronous protocols, and for other people who have been following in your footsteps and building their own applications on top of the newer versions of channels and the ASGI spec.
So like one of the biggest problems I certainly run into a lot myself is just debugging this stuff. Like it's so hard to understand everything that's happening at once. Because often you have like maybe 10, 20 coroutines happening all at the same time. Putting a debugger into one of them is more difficult than it maybe could be. And also there's some weird side effects. A lot of the time you'll get bugs where things run slightly too close and run over each other. And as soon as you put a print statement in, you put just enough delay and they now run separately and the bug goes away. And so there's really sort of a almost quantum level of like, if you look too closely and put too much debugging in, it just fixes itself, which is really annoying to deal with until you realize what's happening. There's also other problems with like Python's async framework is still a little bit sort of patchy in places. There are problems like, it turns out you weren't yielding properly. And there's solutions to this in async.io and core Python, but there's still a few places. 3.7 helps with a lot of those. I think there's still some more we could do as a Python community to patch up async.io and make it a little less, rough around some edges. And in general, just using channels and debugging that way, a lot of people run into problems around understanding how things are flowing through the system. Like the tracebacks look entirely different, right? Like there's all this channel stuff in the middle. Middleware works a bit differently too. There's a bug we only fixed that I think last month where for a long time middleware was being created every single request in channels, and it wasn't being done like this in Django. So people are like, that's weird. My pages all work, but they're really slow. And it turns out they're doing a lot of work in their middleware's init method. And once we fixed it, that went away. But it's all sort of these slight differences where like we are close enough to Django, almost the uncanny valley of differences starts cropping up. Like, oh, this works a bit differently, or these are asynchronous APIs. And like, especially when new to Python async, understanding the intricacies of how to call async stuff can be a bit surprising. We try to help some of that in channels in Django, but there's still some rough edges that, we just can't help with. Like, you just have to await things. If you don't await something, it's not going to happen. Except it might happen sometimes because, of course, that's how good bugs happen.
It never works except when it does.
Yeah, it's the best bugs are ones where you're like, well, if I don't await, it works like 30% of the time. There's enough left in the scheduler to actually run the thing anyway, but the rest of the time it doesn't get there, and it's just like, oh, it's the worst kind of Heisen bug basically. And it's, async programming is sort of a lot of those kind of like very unpredictable, very like non-consistent bugs, and debugging is mostly me just like running a thing 3 times, try and get it roughly consistent, see what's happening.
Yeah, and as you were discussing the ORM layer, one of the other things I was thinking about of parallelizing things and not putting enough consideration into it is the risk of running out of database connections and some of the fun debugging sessions that leads to as well.
Oh, totally. Like we've already had problems with that. People just try and do that themselves, right? Like you just get way more connections when you're running async. Like you can run like hundreds of things in parallel on one process. And at some point you start hitting like these core limits on database software, or like you hit like file socket limits as well. We've had that crop up recently. It's a standard problem for most web stuff, but it happened much quicker than I expected. So yeah, like all these things, like you never really think about them normally with normal Python, but all the things come out of the woodwork to try and find you when you're running async. All the things you never quite thought about too much.
Yeah, everything is easy until you scale, and then weird stuff starts to happen, like network saturation or TCP collisions or any number of other fun things along those lines.
Exactly.
And as we were discussing the asynchronous interface and some of the confusing aspects of building an application in that fashion, what were some of the design considerations that you worked through as you were building channels, both 1.x and 2.x, and some of the lessons that you learned from that initial implementation as far as how to structure the interfaces that you expose and the internals of the application to help reduce some of that confusion and give people launching off point to be able to get something up and running quickly?
Well, so the main part of that is like safe defaults, right? It's very Django philosophy of the thing we give you by default shouldn't be too dangerous. A big one of those is deadlock prevention. The design of channels 1 and channels 2 is both pretty specifically designed, so it's very hard to deadlock yourself. Consumers can't wait on a message from another consumer. Like the easiest deadlock is two things both wait for each other and then just get deadlocked. So like there's a little bit of design there, like, oh, you have to build everything as like it receives a message and then your code gets called. So everything's sort of reactive. That helps design quite a bit. There's some things we just can't solve though. Like we just can't solve, you might run a synchronous function and it blocks the whole process. That's a weakness of Python's asynchronous implementation by itself. We can provide easy ways around it. So it's sort of like, oh, here's a very easy way to stop this happening if you manage to get here and read the docs. And like we press it in the tutorial, in the quick start guide, in the code examples, like, hey, if you want to call synchronous code, use this sync to async wrapper. It does most of the safety for you. But there are some cases where we just can't stop that stuff. Other cases, we try to make it safe for things like, especially in channels 2 being more familiar. So channels 2 uses standard Django URL routing, whereas channels 1 didn't do that. And so it's trying to make it so like, if it's familiar to if it's like Django, then it's going to be what you expect and work as you expect. And if it's different, we try and make it obviously different, like trying to make that API feel a bit more dangerous or feel a bit more unusual. So you might get an idea of how it's shaped or might have an idea to go away and look up how it works. And then try and reinforce that through like just examples and documentation.
And in the process of building channels and the upgrade to channels 2, you have developed a new protocol for asynchronous web applications that in some ways mirrors the WSGI protocol that we've had for a long time. And we've mentioned it periodically as being ASGI. So first, can you break that out as to what that stands for and how it differs from the WSGI standard and the overall process that you went through for being able to develop the specification?
Totally. So I mean, the joke is ASGI is just WSGI with an A in it, right? So the idea is ASGI, ASGI stands for Asynchronous Server Gateway Interface. And in many ways, it's just literally like, it's meant to be a spiritual successor to WSGI, to WSGI, right? And so having a similar name is a very obvious homage to that and meant to signal, hey, this is meant to be like that thing. There was a sort of previous thing that was called ASGI 1 with channels 1. That wasn't really a specification as much as like, oh, here's kind of how channels works. But with channels 2, what I've really tried to do is take a long, hard look at WSGI and what it did right and try and replicate that for the modern world, right? Like, there's been lots of discussions over the years about, oh, how can we make a new WSGI? How do we make, like the next version of it? There's been discussion on like the web special interest groups over the years. And it's always kind of petered out because WSGI in some ways is such a strict thing. It's hard to take a thing and call it WSGI while making it asynchronous. So my hope was to do like a half step. Here is a thing that is asynchronous. It's a little bit different to WSGI on purpose, but it has that same kind of through line of, it's quite simplistic. You can write applications as a single object. It's meant to be easy to understand and have a basic sort of API that if you want, you can just code against raw in Python. There's no need for a complex framework or anything like that. So that's kind of the driving force behind having ASGI. And of course, like the idea of WSGI was, when it was invented, there were web frameworks like TurboGears that only ran on one web server. Like you had to use CherryPy. And so the idea was like WSGI tried to make things more open. gave you a choice of frameworks and a choice of servers that you mix and match. I want to bring that forward to the asynchronous web world too. Like, I want to have that from the get-go almost. Like, hey, you can develop in Django, you can develop in Flask, you can develop in anything else, and you can run it on any of the other servers, and they all interoperate in the right way. And like having that standard, giving people the option not just to use existing stuff, but also to really open it up. So if you want to write a new web server, you can go for it. You're not limited to trying to convince a framework to come along and say, hey, framework, can you really add support for my thing? Like, no, you have this specification. It's quite loose. It gives you a lot of freedom on the implementation side. And it really lets you explore that stuff. And hopefully it will really encourage more innovation with Python frameworks and Python servers as well.
And a little while ago, at least a year ago, maybe even two at this point, you joined Corey Benfield on this podcast to discuss the early days of channels and also the then proposal of the WSGI 2 that was being discussed. And I'm curious if ASGI in some ways has become that WSGI 2, or if there are still efforts being made to try and upgrade WSGI itself to support some of the newer protocols such as HTTP 2 and things like that.
If there has been progress on WSGI 2 recently, I certainly haven't heard about it. I think a lot of the discussion died about the time of that old podcast. In many ways, like looking at the way things work in Python especially, I was pretty convinced the best way to approach this wasn't to just discuss in a vacuum. It was to go away, implement it, get multiple implementations, really hash out that problem-solving part of the process with actual software, and then come back with a real living specification and go, hey, we've done this, we've implemented it, it runs websites now, we know what the holes are, we understand this much better. That's kind of how WSGI works in a way, and that's kind of what I'm trying to do with ASGI as well. And I think at this point, it seems certainly from my biased viewpoint, ASGI is being seen more and more as a WSGI successor. I was being asked just this morning on Twitter if there's going to be a PEP and when there's going to be a PEP about it. And like, I have to really look into that and start down that process as well. But that is my intention at this point. Like, I am now satisfied that the thing I sort of dreamt up as ASGI 2 and has been refined with the help from so many friendly people over the last 2 years is ready to take on that mantle, right? It seems stable. Everyone I've talked to pretty much mostly likes it, which for a protocol, it's as good as you'll get. Like, no one ever likes everything perfectly. As long as everyone's like, oh, it's fine, I'm cool with that. That's as far as I can a success. And so the next step really is like, where do we go from here? Like, do we probably, like start the PEP process, like start that process of making it more official, like as more and more frameworks are just taking up the mantle. Like, we had a sort of small discussion at PyCon in the US with a few sort of server and framework authors about this, but I think the Python 3 train continues apace, and behind that it pulls the async train and thus the ASGI train too. So I really think like the time is definitely fast approaching for much, much more adoption of that across the spectrum.
So ASGI is the caboose on the async train.
I guess if the analogy continues, yes, exactly.
And have you been seeing a lot of buy-in and other uses or implementations of ASGI with other frameworks beyond the work that you've done with channels too?
I have. I mean, the most obvious and impressive one is a lot of Tom Christie's work around Django REST framework and Starlet and all his stuff. He's honestly done a lot of the heavy lifting with this stuff and really like done that really important second full implementation of everything. Like, there's Uvicorn, which is a standalone separate server. He's got basically 2 different frameworks as well on top of it, and like one's minimalist, one's quite much more fully featured. He's been like giving me all this wonderful feedback on the tracker, and also people he works with and other people around it. Like, that really is a great sort of thing I've been looking at. Like, oh, it really does work somewhere else, and like the idea of having this middleware we can truly share across frameworks does actually seem to work in the end too. So that's been particularly useful. I'm going to give him and the people who work on the projects he leads a lot of credit as well.
And do you have any particular hopes for what the community is going to do with ASGI, or any updates or revisions to the standard as it stands right now that you want to see implemented before ASGI gets cemented in the form of a PEP?
I think at this point, it's mature enough that the PEP process would in itself thrash out the final details. There's a few rough edges that, I'm always perpetually unsure about. Like one of the things I can speak to as an open source maintainer is it has been about a decade of being unsure about everything. So at some point that's kind of come to the territory. But like there's like, the PEP process and all the things surrounding it, and also other people implementing that specification is that final thing we need to really seal it up and make it good. And one of the things is like we've made, like there is a version field in the ASGI spec, right? We made sure that like we're not going to get stuck in a corner again and make it unextensible. The idea is to make it a bit more living than WSGI was, to adapt more to the different flow of stuff. We've separated out, for example, the basic structure of an application, about how you sort of build a thing that receives events and sends stuff back from the protocol. So like there's a HTTP spec, there's a WebSocket spec, there's some sort of in-development specs for other things too. And the idea is if something comes along that's new, we can hopefully make a protocol spec for it separate from changing the fundamental design principles of ASGI. And that's kind of part of that too.
And do you have any particular plans for the future of channels itself?
I do. So I posted a blog post, I think at this point, quite a few months ago, about like what's next for Django and channels, right? And I think a big part of that is eventually taking things we've learned from channels and putting them into Django. I never want Django to do WebSockets. I think channels' future is to become the WebSocket solution for Django. But I think Django itself should do asynchronous HTTP. Like Django should gain asynchronous web middleware, asynchronous ORMs, do long polling natively, all that stuff that Django is sort of more familiar with. And that's really the challenge here, is to work out what that work is and how to tackle it. Like there's already sort of big buy-in from the community. I posted this sort of rough plan online. There's like on the Django developers list, a lot of positive feedback on that. People are just very keen for this to happen. And the next big step is to sit down and work out like, how are we going to run this thing? It's going to be like one of the biggest changes to Django, probably in the last 5 years at least. So like, how do we do such a big change? How do we make it like we don't have this sort of branch that's never merged? It's often a big problem, right? Like a couple of projects in Django's past have done amazing work on a branch, and then the branch has never quite landed, right? Like for a long time, we've had a composite primary key branch with like, oh, you can have composite primary and foreign keys, but it was always a little bit like not mergeable or something, and like it just drifted away over time. So that was kind of sad. I think this is like trying to do that here, and also at the same time control like my particular commitment to this, right? Like I don't want to overcommit myself or become a single point of failure. I'd love to try and bring on some like new big Django contributors from this too. Like this is one of the best things of bringing on like new people, is to have this big new thing you can really sink your teeth into. Django has been not quite, but like there's been a lot of like difficult like security bug fixes for a long time, and not a lot of brand new features. So this is like almost a nice piece of fresh ground for us to use for that too. So there's a lot of different facets to what it becomes, and it's also fluid, right? Like every Django con or PyCon I go to, I try and talk to people, I try and get the feeling of like the room or the conference and try and understand who's where, and it sort of develops over time. But I think at this point, the goal is to take channels, make it like sort of the WebSocket handler, move some async stuff into Django proper, and then maybe things like Daphne, maybe like if Daphne gets replaced by some other good web servers, just retire it. Like if it's being sort of the same job as being done by other people, just say, hey, like this served its purpose, it was a good reference server, and we don't have the people to maintain it, but there's other ones you can move to. So like really like, I'm not afraid to be very frank with myself about like what has to continue, what doesn't have to continue to. Like where is this, what is best for Python as a whole as well as for Django?
And what have been some of the most interesting or unexpected projects that you've seen built on top of channels?
Oh, this is fun. Every PyCon I go to, someone comes up with a new amazing thing I've heard about. So I mean, there's a slew of things like chatbots or real-time stuff. There was at least one person who had like an RPG they were making with it, like an online web game. That was pretty fun. I like that one. They had some fun questions. A lot of people doing like Uber for X. That's way too common, in fact. Like every other week I get a thing like, oh, I'm trying to like plot stuff on a map and find what's closest to somebody. I'm like, you're making Uber for X, aren't you? Like, mm-hmm. So that's very common. But also there's some fun things like I like the games the most. Like, I came to programming through games originally. That was always my passion, like with many other people as well. So I love seeing it used for like weird little games or like backends of stuff like that. but there's been some good stuff too. I think there's one that involves space, and space is always very interesting to me. I forget what it was, unfortunately, but yeah, anything unusual like that, I'm very excited about.
And are there any other aspects of the work that you've been doing with channels and the ASGI specification and your thoughts on the future paths of those and Django that you'd like to discuss further that we didn't cover yet?
I mean, a little bit. Like, let's get a little bit into like sort of the philosophy around this, right? Because like sometimes people look at Django from the outside, but like, oh, Django, it's this venerable institution. It's staffed and maintained by this who's who of Python developers, like, all that kind of stuff. But in reality, a lot of the Django developers have moved on or changed to do other frameworks, or, it's been over a decade. And so the thing really here is to not just make this something that's important, make it sustainable, right? It's really important to me that however we do this is something that is not going to burn out more people. We're not going to like just churn through one or two more developers and like spit them out the other end and make them like just not program for a year. And like that's really the difficult part of this. And part of that too is like when I say it's important for Python as a whole, I really mean it, right? Like Django is important, but I don't believe Django is the future of Python web forever. And that's a foolish perspective to have. I'd hope that there's be something else that will complement it in future, if not start replacing it. But it's really the case of like, how do we best serve that stuff? And it's really hard to do that because you don't know what the future is. Predicting the future is very difficult. Like I've tried and tried again over my career in both commercial software and open source to try and predict the future. It usually goes quite poorly. Sometimes it works and people say, oh, Andrew, you're so good. Like I was lucky at that point. And so it's really like, how do we make it flexible in a way where we don't get stuck again with, oh, we have WSGI, we can't upgrade it. And also everyone who knows about it is just not willing to work on it anymore. And that's kind of the hole we were stuck in there for a while. So I really think it's important to not just think about how we build new specifications protocols, but also who builds them and how we come together to organize and discuss and do that part of the open source movement that's often kind of ignored.
Yeah, and I have to say that channels itself is definitely an impressive feat of engineering, but one of the things I was most pleased about while I was reading through for this show is the fact that you implemented ASGI as a separate concern and something that lives apart from channels itself and enables everyone else to have some focal point to build off of without everyone having to go and reinvent the wheel in their own special way and start to fragment and fracture the capabilities and approaches of the Python community, because WSGI has been very valuable up to this point of providing a very standard implementation of a web interface. And it does have its shortcomings, and there are other projects such as Tornado in particular that allow you to take different approaches, but having one common obvious way of doing things gives everyone else a good reference point to either build off of or take as inspiration for their own work.
Yeah, and it's one of those things like when you make a protocol like ASGI or anything similar to that, a lot of it's not making like, oh, the obvious good choice. It's making the choice between two both bad options, right? There's a lot of trade-offs in the design of ASGI, and this is true of WSGI too. Right? We're like, well, we have this problem when neither solution is good. We've got to pick one of them. And like that's the value of having a specification. The value of having a specification like ASGI is that we've taken those choices, we've made those choices, we've justified them in some cases, like why we went down that path. And consistency is more important than perceived betterness. Like a protocol spec like this will never work for everyone. Like ASGI is not going to be perfect for every single implementation of asynchronous web stuff. Someone will always fall outside the sphere we've drawn for ourselves. But our goal is to be there for like 95%. Like it's the good common use case where you can pull on that common idea and understanding of like, here's all the docs, here's the tutorials, here's the servers, here's the frameworks, and you can operate inside that sphere. And if you get big enough or special enough or high traffic enough to do something differently, at that point, you probably know enough that you can look at ASGI, change one of our trade-offs for your trade-off, and go down a different path. But I think having that information there and having it separate is really important. Like, just recently, in the last couple of months, there's now a separate website for ASGI that says, like, has the specs, has like some extension discussion, has a list of things that implement it, to try and build it as a definite, more separate identity to Django.
So for anybody who wants to follow you and keep up with the work that you're doing, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose a new podcast I started listening to recently called Nobody Listens to Paula Poundstone. And as the name suggests, it's Paula Poundstone waxing poetic about various topics and being her humorous self. I will warn that there has been some profanity in some of the episodes, so probably best not to listen with small children, but it is very enjoyable and amusing. So with that, I will pass it to you, Andrew. Do you have any picks this week?
I have one particular pick this week, which I really love, which is a wonderful blog post. I'll send a link to put in the show notes. It's a literary appreciation of the Olson time zone database, which, among other things, shows the separate time zones for World War II. If, like me, you're a big nerd about time zones and language and things, it's a wonderful breakdown of some of the really weird, like tiny exceptions to time zone rules. You're like, why did this happen? Like, why is there like a 3-minute offset over here? Why did a war have a separate time zone? And it's really fascinating.
It's definitely amusing. And if anyone hasn't seen the falsehoods programmers believe about time, that's always good for some amusement and agony. So I appreciate you taking the time today to join me and discuss the work that you've been up to with channels. It's definitely a very interesting project. And as I mentioned, I appreciate the work you've done with the ASGI specification as well. So thank you for that. And I hope you enjoy the rest of your evening.
Thank you for having me. It's been a great show. Thank you.